Alright, Jack. So this is lesson 4.2. It's a pretty straightforward lesson. I'm going to go a little more in depth than the curriculum does because I think it's pretty important to understand where the basics come from. This chapter is all about equations in two variables, right? When we talk two variables, we're always talking x and y, but we can name functions using other variables. But no, if we use other variables, they would be always the input and the output. Okay, now with this in mind, right, one of the equations we're always going to deal with is what we call slope-intercept form. Okay, and this equation in two variables is always y equals mx plus b, right? And when you're in this form, is always going to graph, right, as a straight line. And we'll see that in a minute here. So what does this mean? Well, when we have these equations in two variables, right, m and b would be replaced with numbers. And a solution to this equation of two variables would be an ordered pair that makes the equation true. Alright, and when we talk ordered pair, we mean an x and a y value, which would be a point on the graph. Okay, so when we take this ordered pair and we plug it into the equation of two variables and we simplify both sides, it would make a true statement. Okay, so taking a look at that, what do we mean by this? If I look at this equation here, this isn't in slope-intercept form, but it is, right, an equation in two variables, right? So, to determine if this, right, is a solution to that, what we're going to do is we're going to say x is 1, y is negative 4. We're going to go over here and put that in. So 3, everywhere I see an x, I'm going to replace it with a 1, so times 1, minus, I'm going to replace y with negative 4, and if I look at this, subtracting a negative becomes plus. Is 3 plus 4 equal to 7? Yes, therefore that point is on the line, all right, or a solution to the equation. The next one, if I plug this in, right, is 3 times 3, right, minus 4, going to give me 7. Is 9 minus 4 equal to 7? No, therefore that is not a solution to the equation in two variables. Okay, let's look at the second one here, right? Determine, pause the video, try it, and see what you come up with. Remember, x is 0, y is 6. So, I'm going to replace y with 6 equals 2 times 0, right, plus 1. Is 6 equal to 0 plus 1? No, that is not a solution to the equation. But if we look at the next one, x is 5, y is 11. So if we replace y with 11, equals 2 times x is 5, so 2 times 5 plus 1. Is 11 equal to 10 plus 1? Yes, therefore that is a solution. Okay, so I know I'm going fast here, but this is more of an introductory. Now, here's what I want you to see, right? When we take all the points that are a solution, what happens? So if we check to see which one of these points are solutions to this equation here, and we plot them, what happens, right? So here, if I replace y with negative 1, so negative 1 equals 2 times 0 minus 1. Is negative 1 equal to negative 1? Yes. So we're going to plot that point right here. Okay? Now let's try 1, 1. Is 1 equal to 2 times 1 minus 1? 1 equals 2 minus 1. 1 equals 1. That is a solution. Let's go and plot that point. Okay? Let's try another one. Okay? 2, 3. I'm going to replace y with 3, and then equals 2 times 2 minus 1. Is 3 equal to 4 minus 1? Yes, that is a solution. So 2, 3 would be a point on that line. Now how about 3, 5? Okay, so if we go to 3, 5, I'm going to replace y with 5 equals 2 times 3 minus 1 gives me 6 minus 1. Is that a true statement? Yes, that is a point on the line. 3, 5. Oh, I'm sorry. Goes right there. Sorry. Now what happens is, when I connect the dots, what does it create? It creates a straight line. And that's what this chapter is about. That if we take these equations in two variables, and we find all the solutions to that equation in two variables, right, what does it give us? And what it gives us is a straight line. So this is what we're talking about, a linear equation, right? And the first form we're going to talk about in a linear equation is point-slope form. All right, now the graph of it is a line, and the line is made up of all the solutions to the equation in two variables. Okay? So now, we could use a table of values, but the curriculum actually wants you to start somewhere else, right? So, we're actually going to scroll down here, and we're going to go to this one. Slope-intercept form. Okay? So slope-intercept form is y equals mx plus b. Now what you have to understand here is m, right, represents the slope of the line, and that's what you did yesterday. Okay? The b is what we call the y-intercept. Now the y-intercept, just to let you know, equals the point where the line crosses the the y axis. Okay? So when we look at this, when you see b, the y-intercept is always the ordered pair 0, whatever b is. Once we know the slope and one point, then we can go ahead and graph the line. So what do we do here? First thing we do is we find the slope. Second, we use the slope to find another point. You have to understand we only need 2 points to graph a line. Now, if your slope is positive, you're going to go up the number of units in the numerator, right the number of units in the denominator. If your slope is negative, you're going to go down the number of units in the numerator and right the number of units in the denominator. We don't discuss anything going left, right? So when we look at this first example, right, and we want to go graph this line, okay? Now I could make a table of values, but what this curriculum wants you to do real quick is find the slope. So if I look at this, y equals mx plus b. So what is m? M is 4, right? Now, anytime we're graphing, we want to change this into a fraction by putting it over 1, right? And it tells me, and this will make sense in a minute, that I'm going to go up 4 units and then right 1 unit. Now, b is negative 5. So what is my y-intercept? My y-intercept is 0, negative 5. So the very first thing I'm going to do here, like the steps say up here, is I'm going to find the slope. Oh, sorry, excuse me. The second step is to plot the y-intercept. Sorry about that. And then the third step would be use the slope. So I'm going to plot the y-intercept, 0, negative 5. Now my slope is 4 over 1. So I'm going to take a journey from this y-intercept, and I'm going to go up 1, 2, 3, 4, and right 1 unit. Now I can keep doing this, and what you'll see is that when I connect all the dots, it creates my line. And if you look at this after what we talked about yesterday, right? Are we walking uphill or downhill? Right? We're walking uphill, and that's because our slope is positive. Okay? If we look at the second one, right? What is the slope of my line? My slope is -2. If I make that a fraction, it's over 1. And that tells me to go down 2, right 1. What is my y-intercept? Well, if b is 3, my y-intercept is 0, 3. So I'm going to go ahead and plot 0, 3, which is right here. X is 0, y is 3. And from here, I'm going to go down 2, right 1. Down 2, right 1. And now I can go ahead and graph my line. Alright? So being able to identify the slope and the y-intercept is important. Alright, let's look at number 3. What is the slope of this line? That is 2/3. Now that's already a fraction. So all we have to do is go up 2, but now we're going to go right 3. Okay, so we go up 2, right 3. Now my y-intercept is at 0, 3, right? Because my b is 3. So I plot 0, 3. Now from this point, I'm going to go up 2, right 3, up 2, right 3. And now I can go ahead and graph my line. Okay? So, with this in mind, being able to graph the line, given this information, is important. So let's go ahead and kind of look at other things they're talking about here. Okay. So, from the practice questions, what they want you to see is the graph of -7x minus 10 is a line that shows the slope and y-intercept to the equation, okay? So, when I look at this right away, what would the slope of this be? We would say -7. Now, when we go to graph, it makes sense to write it as -7 over 1, but when they ask for the slope, they just want -7. The y-intercept is pretty straightforward, right? Now, sometimes textbooks will say just -10, but the proper way is 0, -10. But if you just see -10, they just want you to find b. Okay, so we already talked about graphing. So when we look here, plot the y-intercept, right, at 0, -1. If my slope is -2, it's -2 over 1. So we go down 2, right 1, down 2, right 1, and now I can graph my line. But then what they want you to also do is to write the equation of the line. Right? So if I'm going to write the equation of this line, the first thing I need is the slope, and then I need the y-intercept. Where does this line cross the y-axis? Crosses right here, and that would be at 0, 4. So right away, if my y-intercept is 0, 4, what is my b going to be? It's going to be 4. Now, from yesterday, I have to calculate my slope. What is my rise over run? So, if I calculate this, I go down 1, right 2. So the slope of this line is down 1, right 2. So my slope is -1/2. I can take this information now and write the equation as -1/2 x plus 4. Okay, so again, to write the equation, all you really need is the slope and the y-intercept. Okay? So, the function f of x is shown in this graph, right? We see that. So, the function g of x, right, is -3x minus 1. Compare the slopes by writing less than, greater than, or equal to that in the blank. So if we have this, if we were to graph this line, it'd be 0, -1, right? And then if I go down 3 over 1, I can graph that new line, right? So when we look at it, when